All right, it's Albert Collins. This is my video submission for exercise 7. We were tasked with building a card object and a deck object and implementing them into our main driver. And so the first step I did was create the UML, which is attached in the zip folder for this project. And we were required to build the card class with only 2 attributes, suit and value. So I went ahead and initialized those private values here, and then created the constructor for card to allow the user to pass in the values, or I guess in this case the deck too. When I go through the for loop here, you can see I'll use that. I then created a get suit getter to return the suit, a get value getter to return the value, and then these suit strings and value strings to convert the ints into strings. So yeah, I then created the decked object. And the deck object had 4 attributes: the card suit final, which I set to 4 for 4 suits, ace, hearts, diamonds, clubs. And then for the value, I had a final int of value 13 for ace, 2 through 10. So that's 10 right there. And then 11, 12, 13, jack, queen, king. So that's where these suit string and value string methods come in the card object. So in the suit string, if it has, I had it 1 to 4 incrementing. So if it's a 1, I just called it spades, 2 hearts, 3 diamonds, etc., 4 clubs. And then same thing for the value string, where I only created a values a case for ace, jack, queen, king. And the way it was programmed was to then have the default case be just the value. So if it was a 1, then it's going to be an ace. If it's a 11, it's going to be a jack. And then if it's a 12, it's a queen, 13, king. And then the default value is going to be 2 to 10. And let's see. So yeah, instantiated, initialized. I always get those mixed up. Those values, those final ints. I then decided to create an array list of cards to pass through the object card into the deck object. And I had to get some help from a friend, a couple friends from class. He helped me or realize there's an index that we need to pass through, and we'll see that down below. But I initialized the public deck constructor with the array list of cards and then an index of 51 or 52 cards. So since the array increments starting at 0, we had to go 0 to 51. You could go 1 to 52, but you would have to manipulate the counters, right? So starting at 1, ending at 52, etc. So after we build the default constructor, we're then going to create the deck method, where this is actually initializing those values inside the array list of the deck. So just 2 simple for loops. It's going to run through basically an IJ loop, where the suit is going to be determined, and then the value is going to be determined. So for every suit, we're going to go 1 through 13 4 times. So for aces, hearts, diamonds, clubs, etc., and we're going to go ace all the way down to king 4 times. So that's what this method is doing, where we're using the deck and then the array list add method that's already pre-built. And then I just used the method we created in class with Demland. Well, we didn't create, we had 2 variations of it. One where we constructed the shuffle method ourselves. And then after he did that, he showed us how to use the pre-built shuffle function. So I went ahead and just utilized the inline shuffle function for our shuffle deck method. And then we were tasked with creating like a draw card implementation. So this is where I got some help from a fellow classmate trying to implement this. It was very difficult, and yeah, Noah was able to help me get the index figured out. Where you call the deck, you get the index. This shouldn't be. I guess it is a get index. I mean, this should be index, but get index will work too. I didn't create this, when you have the little wavy line and it tells you, hey, we can create the getter for you. And I created it, and I didn't realize it changed a couple of these values inside my index call. Pretty handy. Anyhow, so yeah, we're gonna draw the card. It's going to get the index. It's then going to go to the array list wherever that index is, and then it's going to pull the card. And then the toString is going to then convert it from a int into a string. And so that's what these two value string, suit string are going to be doing. It's going to tell it, hey, is it a spade? Is it a heart? Is it a diamond or clubs? And is it a 2, 3, 4, ace through king, etc. This was a very difficult assignment. I thought this is probably our most challenging assignment we've had so far. There's a lot of moving pieces, having to utilize the multiple classes, and then using a class within a class, if you will, where card is then used into the deck class. It was a little more involved than what we've been doing, that's for sure, but it was very fun and challenging. And finally, this index get index function was just used to check that the deck is actually decrementing. So yeah, that's pretty much the two methods. So in the main driver, we instantiate the deck of cards. We call it a new deck of cards. Then call the create deck method. I then shuffle the deck, and then I then open the scanner, create the scanner, prompt the user, how many cards would you like to draw? The user is going to enter that input, and then we're basically going to run the draw card method I amount of times, I to the length of the input, right? So if the user inputs 5, we're going to run it 5 times. So let's see it run without further ado. How many cards do you like to draw? I would like to draw 5 cards. Lift it up here. So it draws 5 cards. It drew the 9 of diamonds, 7 of clubs, ace of clubs, 7 of hearts, ace of spades. If you run it again, just to see that it's printing and it is randomized, shuffled, if you will. The deck is shuffling and it's taking the first 5 cards off the top of the deck. I will show that the index is actually de-incrementing here now. This function call. Guess I got to get rid of this. But so we're gonna run it again. Like 5 cards. So 5, it should be 47. Again, that's that indice thing with the index, how our A list starts at 0 and goes to 51. There's 52 items inside the list. So in actuality, there's 47 left to the human, but to the computer, there's only 46 because it goes all the way down to indices 0. So I thought that was a pretty fun assignment. We can also, I guess I won't show it. Yeah, I was gonna say I could show you how I realized we're able to show the whole deck. I wanted to create a method to call it, but I can't do it on the fly here. I deleted it where I basically had the where'd my screen go? Basically had the whole deck being outputted, and but I left it out. It's as simple as I think get list, have another for loop here, and have I go to the deck of cards dot get list. But I deleted that. I had a get list method that I deleted. But while I was building it, I had to use it to make sure that the list was actually being created. So anyway, in that aspect, there was a lot of moving pieces, just building it step by step by step, and um, adding the complexity, continuing to refactor it. Took a lot more time and the help of my colleagues to really get it nailed down. So anyhow, this is my solution for exercise 7 with the guard and the deck. I appreciate your time for watching, and we'll see you in the next one. Thank you.